Yeah. Namaste and welcome to the 15th session enabled by Shibi Anand for AI teacher community. Today we will go through the Capstone Project, a major topic of CBSE Grade 12 AI. And we have with us today Dr. Dhnaya NM, who will be helping us to understand this topic better. Let me introduce Dr. Dhnaya for you. Dr. Dhnaya NM, PhD, currently serves as Assistant Professor at Department of Computer Science, School of Engineering, Amrita Vishwa Vidyapeetham, Coimbatore. She completed her PhD from Anna University for her research in the area of cloud computing. Her research areas include cloud technology, machine learning, and deep learning. She's also interested in areas like Android application development, data science, and predictive analytics. She has 13 years of teaching experience. Before moving to Amrita in 2014, she was working with Sri Krishna College of Engineering and Technology, Coimbatore. She has published several articles in Scopus Index journals and has presented papers in various international conferences. She has also served as a resource person in a number of FDPs and workshops for students. She's a member of Board of Studies for CSPS Department of SKCET. She's at present guiding 3 PhD students at Amrita Vishwa Vidyapeetham. Welcome, ma'am.
Thank you so much, ma'am.
Yeah, and it's an absolute pleasure and honor to have you with us today. Before I hand over the session to you, I have a request to all the participants here. Please keep your mics on mute and you can enable your video. If you have any questions, you can put the questions in the chat box, as in when the relevant questions can be picked up by Dhnaya ma'am and she will answer her session. Over to you, Dhnaya ma'am.
Thank you, ma'am. Thank you so much. It was a great pleasure to meet you people, and whatever I know, maybe I can share with you. For the past 4 or 5 years, I'm working with machine learning, data science, deep learning, because all those things are there in our curriculum. I was very surprised to see those topics in school level. Maybe while we teach, I think the students, they learn all those things and come to our college, I suppose, hereafter. Because even my son is 11th and he is learning Python and all those things. So maybe I think as an engineering faculty, we should be a bit more cautious, I suppose, in teaching. Maybe they'll have all the exposure with all these technologies and then they'll come to our college, I suppose. Thank you so much, ma'am. Thank you so much. Whatever I know, maybe I can try to share with you. And if you have any queries, you can please mail me. I'll share my mail ID, phone number, and all those things. So maybe whatever I know, maybe I can try to share with you. I think already I have seen those logbooks which shared by Shibi ma'am, the basic logbook that the students should submit. Maybe I can start with those concepts which is there in that logbook, and based upon that, I think you have to grade, I suppose. To my knowledge, I think that logbook students will submit, and based upon the logbook, you will be grading those students.
Yeah, Dhnaya ma'am, is your voice echoing? It's coming very sharply. Is the room closed? Is it echoing? Is it?
I think I'm here at my college, actually speaking.
No problem. No problem. I will just adjust the volume from here. No problem. Go ahead, ma'am.
Okay. Okay. So I'll share my screen. What I thought is I'll just give you an overall idea of how to do this, because maybe because the logbook starts from problem identification, then collecting data, but I don't know how far the collection of data is possible. So maybe I can give you some repositories where you will be able to get those data sets, and the analysis, maybe it'll start from there and ultimately end up with a model. Maybe I can share you a textbook. It's a very simple textbook, and all the machine learning and to an extent the deep learning concepts are also covered with codes, with Python code snippets. So maybe it will be a bit more useful for you, those textbooks. I can give you the title, and if you want the soft copy, I have the soft copy with me. That also I can share with you. Okay, so basically what I thought is since this is an online mode of teaching, students, I think they'll be there at different places. I don't know whether they'll be coming to college, or even though they are coming to college, maybe a collaborated environment, it will be easy for them to work, because to my knowledge, I think this is a group project with few students in a group, and they'll submit.
And it is a school-based project, Dhanya ma'am. These are students of grade 12.
Okay, so maybe I thought a collaborative environment will be easy, because all the students are now having a Gmail account and a common platform where they'll be able to edit, or those codes, if they are able to edit parallelly, it will be easy. So that is why I started with it's my Gmail drive. It is just a Google Drive which I have, and there is an option in the Google Drive for creating a new Jupyter notebooks. So the Python codes you will be able to run in the. I think Bindu ma'am already have. Started with those Jupyter notebooks and running Jupyter notebooks. Is that?
No, not the Jupyter notebook. We did it in Colab. She did the code in the Colab.
The same Colab. I'm talking about the same Colab. So you will be able to create a Jupyter notebook in the drive itself, so that, say, if you want to share with few people with the Gmail ID itself, you can share something very similar to a shared Word file or an Excel file. This can also be shared and can be collaboratively you can work. So maybe students can use this same Colab I'm talking about. I think Colab you're already familiar with. So Google Drive, there is an option for creating a new Google Colab. That is Colab in the sense it is a Jupyter notebook online. That is the only difference. If you want, you can maintain a local Jupyter notebook with local installation in your system. But one of the very biggest advantage of this Colab is you don't want to create, or you don't want to install anything. It is very easy. All the packages, or whatever package I'm going to talk about, everything, it is pre-installed. So there is no need of installing it separately and maintain it separately. All those problems, it will be totally, you can avoid. So you can go to any drive or any folder in your Google Drive, and there is an option of creating Google Collaboratory. So there is an option, something like that, where you will be able to create a new Jupyter notebooks, and cell by cell you will be able to run, and there is an option of share. I think all those options you are already aware of. So Colab is one of the wonderful environment where you will be able to create. So as Capstone Project, I think these titles I got from the logbook which you shared. I think it is starting with the problem definition, then the users who are using this problem or using the solution which you're creating, and the students can have various solutions to that, brainstorm and come up with an idea and design a project. Then collect the data. I think the logbook is speaking about collecting the data from local people, I suppose. That was the structure which is given in that logbook. And you have a prototyping and testing. So basically speaking, problem definition can be any problem where you will be able to solve. So you can just think of say some problem which you need to rectify in a local scenario. You can, and the data collection, I don't know how far it is possible, but the logbook tells something like you have to go collect your data with some questionnaire or something. So maybe there is an option, something like that. But normally when we are doing projects over here, I don't know, this live collection of data, it is not really happening. So if you really require a data collection, you can create a Google form or something like that, or some paper-based questionnaire and ask those people and get the data collected, key in an Excel file or something. Then you can use that as your data. That is very well possible. If such a facility is not available, what I am suggesting you is you have so many data repositories are available. So first, the problem, understanding the problem, what problem you are going to solve, that is very important. Then data acquisition, this is what I'm just talking about, collecting accurate and reliable data. So one of the first technology which you can do is go and collect the data live using a questionnaire or a Google form or some form, and collect all those things in the form of an Excel sheet. Then that Excel sheet you will be able to use for modeling and evaluating. That is possible. Or you can you can collect data from some common repositories or some website or something like that. So this is what I thought of doing. First, for problem identification, I think all these concepts you are already aware of. So if you want to solve a problem, you should have all these questions in your mind. That is, where you are applying the solution, why are you doing the solution, what are you going to solve, who's using the system. So all these things you should be aware of. So if you are going for a live data collection, or say if you are trying to solve a problem where you are collecting the data by yourself, you can think about all these questions and create your questionnaires in such a way that it will solve all these questions. That is, ultimately you should get answers to all these questions. It is possible. So as far as data collection is concerned, as I told you, surveys, that is what I told you, say generally if you want to collect a data, you can with a pen and paper, you can start collecting your data with a questionnaire. Or say if you have a data in the website, you can use some web scraping technology. Actually, I'm not going to deal with the web scraping. Actually, Python, one example I'll tell you, say for example, if you want to collect some data about, say, our IRTCT site website, that is railway reservation website, there's a portion that is called comment section. So you can write codes in such a way that you will be able to collect all those comments, and say you can do an analysis on those comments. Say what is the general feedback of the people, those who are using this website. Say somebody will tell this website is too slow, I'm not able to book my tickets or something like that. So if you want to do some sentiment analysis, something like that, you can collect those data. Then the third one is a sensor data analysis. Say for example, say temperature, small sensors are available. Say IoT devices are available where you will collect your data from sensors that is available. So those sensors, once you write specific codes or IoT devices, if you have, you will be able to collect your data from those sensors, and that data you will be able to use as your analysis. Then you can have cameras where images, you will capture images or videos. So you can have video analysis, you can have image analysis. Then you can have some APIs. Say for example, if you want to collect something from Twitter or Facebook, say I just want to collect all those Facebook comments for a specific post, and I just want to find out whether it is a positive comment or is it a negative comment. That is it a positive feedback from the people or from a negative feedback. You can use Facebook APIs, or say for example Twitter. The very popular example I'll tell you, say demonetization. I just want to collect all the tweets of which is related to demonetization, and I just want to analyze whether what is the sentiment behind the demonetization, whether everybody are favoring demonetization or all are against demonetization, or is it a neutral scenario. So for all such scenarios, you will be able to get your data from Facebook or Twitter or some social media platform using APIs, because there are APIs where you will be able to get data from the social media, say Facebook, Twitter, or any other platform. I think there are some restrictions in the even Facebook. I think you will be able to collect only public comments, and some restrictions are there, even though there is a possibility of collecting live data from the social media using APIs, and you can use that data as your analysis background. So all these things are possible. Other than this, say web scraping, surveys, sensors, or all those things, you can have very popular repositories are available. That is, the first repository is called Uci Repository. Maybe I can share you all these links with you. Uci Repository is a very popular repository where you will have so much of data sets that is already available data sets, something similar. You can just browse and see Iris data set. Iris data set is one of the very popular data set, which is, say you have petal length, say it is as a flower, that is based upon the flower characteristics. You are going to classify your flower, say sepal length, sepal width, petal length, petal width. You have those 4 details with you, and based upon these measurements you can classify those as, say, iris setosa. You have 3-4 categories of flowers you have. So say for example, similar, very simple sense, say if your petal color is red with such a wide say this much length, maybe you can categorize that as hibiscus. I'm just telling you just example, something similar. So something similarly, you have wine quality data set, wine data set, heart disease data set, car evaluation data set. You can just browse through. You have so many, such a wonderful repository it is. You have so many data sets are available where you can use this data set for analysis rather than collecting data live from the community or something. Okay, so that is one of the repository. Then you have another repository that is called Kaggle. Can I move this? Yeah. So I have another repository that is called Kaggle dataset. That is Kaggle dataset. It is kaggle.com is a very popular website where you will be able to collect. All these are free, freely available dataset. I'm talking about all these are free. Then Kaggle also you will have, say you can see so many data sets are available. Majority of the data set is in the form of CSV file, that is Excel file, or it can be in the form of images, videos. All these data sets are available. See, you can search for such category. Then you have AWS data set where you will get, this is called Amazon Web Services, where they are providing you a wide range of data sets. You can just browse through, you will get data sets from this. Then our government's website, our data.gov.in is having a series of data sets available where you will be able to take all these data sets and do your analysis. So similarly, you have World Bank data set, then you have Group Lens data set, you have Google query, big query data set, and some GitHub accounts where you have category wise, that is what category of data set you want.
Yeah,
Yes,
Dhnaya ma'am, there was a question from Ruhani ma'am. She had asked, can students use GitHub repository? I think you just answered that, I think.
Yes, ma'am. Yes, ma'am. Of course, because GitHub is the easiest way you can. So GitHub, any account, ma'am, because I don't know the live data collection, how far it is possible with the students. So if you have a GitHub repository with your data set, you can use, maybe I can show you an example, how can you use those GitHub repository in your Google Colab, so that you can take those data sets and you can start processing. So these are some repositories where you will be able to get your data. Then you have classification. Generally, the analysis can be of so many different category of analysis you will be able to do. One is called your regression analysis. The simplest terms, you have so many analysis. One can be a regression type of analysis. Another one can be a classification type of analysis. Then analysis can be in terms of image processing analysis. That is image classification and image analysis category is possible. Then as I told you, something like say sentence, you have data in the form of sentences, say some sentence from the Twitter. Then you want to analyze those sentences and find out what is the general sentiment of the people. Say I'm putting a post, I just want to know whether the people are favoring that post or people are opposing with that post. So from the comments, see, comment will be a total sentence. You can take those sentences and find out whether that sentence is a positive sentence or a negative sentence. You have so many technologies that are available. So for finding out the sentiments. So all these analysis you will be able to do. The very basic analysis you will be able to do with the data is either you can do regression in the sense, say for example, if you want to predict some values, say I have a set of house, that is a very popular example where machine learning people will use, say house price data. Say I have 100 house data with me. Say for example, I have first column, I have number of rooms, then I have number of bathrooms, then I have say square feet, then locality, all these information I have. Then the last column I have, say if your attributes are so and so, that is if my house contains 2 bedrooms, 2 bathrooms and 1000 square feet, and the locality is say Coimbatore, the peak RS Puram, then you can say the house price can be around say 50 lakhs to 60 lakhs or 50 lakhs or say 55 lakhs. Or say the next data I have, say I have only 1 bedroom, 1 bathroom, and my house area is around 800 square feet, and it is say somewhere in the village area, maybe it can reduce up to say 30 lakhs or something. So if you have such a data set available, and say I have my housing attributes with me. So already what I'm going to do is I have all the data sets with me with all these information, number of rooms, number of bedrooms, square feet, locality, all this information, and the price is also with me. And I'm going to train my system in such a way that once I give the attributes, it will predict and tell me more or less what is the price I can expect for my house. Say I have 100 house data with me, so I started training my model in such a way that it will predict and give me, if I'm giving the attribute, say I'm telling you I have say 3-bedroom house with me with 1 bathroom, and say the square feet is say 1210, and my locality is so and so, what price I can expect. That is, you have a model which you have created in such a way that it will be able to predict those values, that is house price or say whatever it is. So continuous values, if you are able to predict such kind of predictions, you can call in the category of regression. Or the next type of analysis which you are able to do is called, say I have a set of customer data with me. Say customer data in the sense, what are all items he is purchasing, what is the total amount he is purchasing at each and every purchase, etc., etc. Some information I have, and ultimately I have a question of whether he'll buy a new product or not. So that is whether he'll buy or not is in the form of category of 0 or 1. That is whether he'll buy or not. So such kind of problem. Say another example. Say Gmail. I think Gmail. What they'll do is say once you get a mail, automatically it will be classified into spam. If it is not spam, it will come into your inbox. This is what normally Gmail will do. So what Gmail it will do is it will go through the contents of your mail. So it will read through all the contents and it will classify your mail as spam or not spam. So that is called your classification. So generally, very simple analysis if you want to do, the general analysis can be categorized into 2. One is called your regression analysis. Another one is called your classification analysis. So these 2 kind of analysis you will be able to do, rather than this is not the only kind of analysis. You can have text analysis, as I told you, sentiment analysis. Then you can have recommendations. I think those who have done with Amazon purchasing, once you purchase something, at the bottom it will show you those who purchase this item, they purchase so and so along with this. That is, if you start purchasing bread, then Amazon will show you those who purchase bread, they started purchasing butter or say jam also. So those recommendations, that recommendation is coming with your purchase pattern. So you can do recommendations, you can do sentiment analysis, you can do simple value predictions, you can classify, that is, you can categorize those under classification. So all these analysis you will be able to do with your data set. So similar data sets you can select from these repositories and do your analysis. So that is the first step. The step number 1 of your project is what type of analysis you want to do. Is it a regression? Is it a classification? Is it a sentiment analysis? Is it a recommendation system? Or is it an image classification? Because the pattern of analyzing your numbers is totally different from your analyzing images, because images are coming under totally different category. Or are you doing some say drowsiness detection? That is, all those things are very popular. Say if you are putting a camera on a driver, just the eyes of the driver, if you continue capturing, if he started closing his eyes, maybe you can raise an alarm saying that he started sleeping. So drowsiness detection, all these things you will be able to do all these analysis. But say drowsiness detection, if I'm telling you, that is in the form of a video analytics. So it is a video analysis. So before doing a project, just see what type of analysis you want to do. The basic analysis is regression and classification with the numbers. That is the easiest analysis you will be able to do. But rather than that, you have so many analyses is possible. So first thing is understand what analysis you want to do or what problem you want to solve with your project, and identify a specific data set from any of those repositories. These repositories are having so many type of data sets are available. It can be numbers, it can be say numbers with some category, numbers with strings, or it can be a paragraph, it can be image, it can be video. So all these things are available. So first, identify which domain you want or what type of problem you want to solve. Then you can search for a data set in any one of those repositories. Again, while you select a data set, make sure that it is easy for you to process, because some of the data set which is given in this data repositories are too huge, in the sense GBs of data will be available, but I don't know whether we'll be able to process with such a huge data. Because Colab, if you want to process with the Colab, your data should be either, it should be there in a public repository like a GitHub where you can directly able to use this, or it should be there in the drive. These two are the options which you have to explore. So if you want to upload your data set in your drive, say 1 GB or 2 GB, I don't know whether you will be able to upload all these things and you will be able to process. So make sure that you have a reasonable size data set and then start your process. So these are all the things you have to analyze before you start doing a project. Do you want any more clarifications, ma'am? I don't know. Ma'am, mute, ma'am.
I'm so sorry. I think I saw one question in the chat box, which asked, sir asked that what do you mean by sentiment analysis? So when I did a quick check, I posted, but if you could just throw very simply what a sentiment analysis is.
In the sense, say for example, something similar to the very same example I'll quote again, demonetization, because it is so popular. Say demonetization, once we declared demonetization, Twitter was coming with a large number of tweets with, say, few people they are supporting demonetization, few people they are not supporting demonetization. Somebody was totally neutral. That is, they are not supporting, not defending, nothing, neutral. So say something similar situations, you can get those tweets, live tweets, or say there are APIs that I told you, APIs are available where you will be able to get tweets, previous tweets. Say for example, demonetization happened 2-3 years back.
Yes.
So you will be able to get those tweets, and see tweets will be in the form of sentences, because tweets, I think there are character limitations.
Yeah.
Say 120 character or say 256 character long text you will get the text and analyze those texts. Because see, generally how can you we from the sentence while we read, we will understand whether it is a favoring sentence, or if it is a negative sentence, or is it a neutral sentence. So we have to make your machine understand that. Say we know, say once you read a tweet, we can understand is it a positive tweet or a negative tweet or a neutral tweet. So in sentiment analysis, what we will do is, we will give a set of say 100 tweets we will give to our system and the corresponding sentiments. From the sentiments, say if you are giving 101 extra tweet, from these 100, it will learn, the system will learn by itself and say 101 tweet, it will say, okay, this is a kind of positive. That is, it is this guy who posted this is favoring demonetization, or he is not favoring, or something like that. This is called your general sentiment. Say railway ticket booking system, there is a point that is called comments. So those comments, if you start reading, some of them they will say, yes, the site is wonderful, super, I am able to book whenever I want to book a train ticket. But somebody will say, see, I don't have this option, I'm not able to do this at all. So something similar for any website or any services, we can get those comments and say whether people are liking our service or not. That is generally, we can call that as a sentiment analysis.
Thank you so much. I think Kashvinathan sir, your doubt has been clarified. You can go ahead. The teachers who have taken AI in grade 12, if our participants are already in grade 12 AI, if you have any questions, this is the right time to put your questions in the chat box or take your turns to unmute and ask her so that she can address it as she's taking her session. Okay, thank you, ma'am. Go ahead.
So the next, I will tell you a very simple example. This is one of the very simple example. If time permits, I will show you one regression and one classification, how this analysis. See, once you get the data, say assume you got data from one of those repositories, data is ready with you. How can you do analysis? Okay, so you can do actually machine learning and deep learning. I think you would have seen that curve. You have an artificial intelligence on the outer side, then you have a machine learning, then you have a deep learning. So there is no drastic difference between a machine learning and a deep learning, because ultimately both will do almost the same. But the thing is how fast it is doing, how quickly it is doing, how big your data is. So normally what we will do is we'll apply deep learning on a very small data set, but there is no use in applying deep learning. At times maybe machine learning will outperform your deep learning. So there is no point in saying deep learning is much better than machine learning. So I'm not going into those topics. So I'll just tell you a very small example. Once you get a data set, how can you analyze your data and make it predict something? Okay, so say for example, fuel efficiency of a vehicle. This data set, I think you will get this data set from the Uci Repository. I think I can show you how to access this from the Uci Repository. So fuel efficiency of the vehicle, I have a data set where I want to predict the fuel efficiency of the vehicle. So this is what my problem is. So as a first step, as we have already learned, it's called data collection. That is, go to some repository and collect such a data. So UCI repository is already having an auto MPG data set is already available. So I'm going to get that data set from that. Then I got a data set with so many rows and so many columns. The next thing is I just want to find out which column I want to predict. That is, say what I want to do with that data set. So that is the next one. Define your problem statement. Then EDA, I think already you are familiar with EDA, say with pictures, say storytelling with the data, exactly similar. Say before doing anything, you can get some idea about your data with some visualization or some small analysis. What is the average? What is the mean? Is that okay? Do you have any outliers? That is outlier. Maybe while coming, I'll just tell you what is an outlier is all about. Then all these things you will be able to do. Then prepare your data, because if you want to apply your machine learning model or a deep learning model, whatever model you are going to apply, your data should be in the form of a numbers. So that is the only data which is accepted by your machine learning model. I think I'm talking in terms of Python. So if you want to apply your data or data to your machine learning model, that data should be in the form of numbers. Say for example, I have one column that is called say category. Say in this case, I have a vehicle name. So vehicle name is in the form of a string. It is not a number at all. Say mileage, you can say that is in the form of a number. Say number of wheels, a number of doors. All these things you can say in terms of numbers. But car name, you can talk in terms of only string. But the string, it won't be directly, you won't be able to apply the string data into your ML model at all. Before that, you have to convert those strings into numbers. Then only you will be able to proceed. So all these things are coming under data preparation. Then you have so many models available. See, regression itself, you have linear regression, you have decision trees, so many regression technique itself is available. So what technique you are going to apply, or are you going to apply multiple techniques and compare those accuracies? Then last one, I think it is a bit advanced one, is a hyperparameter tuning, because while doing your machine learning, you have so many parameters where you will randomly select. So this randomness, of course, it is going to affect your model. So instead of taking this as random, you can have some choices given and find out which choice is better. So that is called your hyperparameter tuning. So all these steps you will be able to, or you have to do for your making your model perfect, because ultimately your aim is make your prediction accuracy. That is, if you give a new data, your system should predict with high accuracy. That is your ultimate aim. So all these things you will be able to do. So first we will start doing a data collection. Say for example, you have a repository that is called Uci Repository. So we what we can do is there is a command that is called wget. What this wget it will do is it will get you your data from your Uci Repository. I think you have given the data the data link. Something similar, somebody was asking how to get from the GitHub. That is also possible. Maybe I can show you with an example, say a random example, maybe if it is available, I can show you, say GitHub, say I'll open my GitHub, I think that will be better. So I have a GitHub, say you can find out the data set in the GitHub. Say I have a data with me, say data_salary.csv. This is the data which is available in my GitHub. So what I can do is I can just click on that, and you have an option that is called view raw. That is the raw data, you will be able to get that. So this will be the once you give this raw data, this link, that is you can see a link at the top, this will be the link to your data set. So you can copy this and you will be able to, maybe I can just create a new a data, and I can say data is equal to pd.read_csv of, within quotes you can give that link, the link which I copied from the GitHub, that is GitHub raw GitHub data. You will be able to access only with this prefix of this raw dot, then only you will be able to access that directly in your Colab. Then what will happen is you will be able to get that data in your Jupyter notebook. This is how you will be able to access your data from GitHub. So any GitHub, that is whatever, that is one of the examples. So you will be able to access those things. Again, I'll tell you one more package. Maybe you can go through all those package. Pandas is one of the very popular package where you will be able to do all these pre-processing and analysis. Pandas package, then Matplotlib Seaborn, I think maybe you would have seen that in the visualization classes. So these Pandas along with Matplotlib and Seaborn is one of the very popular packages in Python which is used for data analysis. Pandas is one of the very popular package with so many functionalities are available. So this is how you will be able to see. wget is a command for directly getting those data set from the GitHub repository, and once you get this, you will be able to see that data over here. I think you can see the data set over here. The data set is auto-mpg.data, so that will be downloaded in your Jupyter notebook itself. So there is an option like that. Then the next thing is read your data as usual. I'll tell you a few options, maybe not extensively. Data can be in the form of .csv file, it can be .data file, .excel file, all these things can be, that is all these extensions you will be able to see your data. That too, it is a very simple data. Say if the data is in the form of image and something like that, it is in a totally different structure, it will be there in a folder. Say I'm just talking about a very simple data set in the form of a CSV or Excel or something like that. Pandas, there are functions for reading those CSV files. That is, you have read_CSV is available, read_Excel is available. All these functionalities are available for reading your data. So the first thing, download your data. I'm just closing this. So download your data and start reading your data. So once you read your data and it is there in your Jupyter notebook, then you can start processing with your data. Okay. So ultimately, once you finish reading the data, your data will be something like this. That is MPG, cylinders, as I told you, displacement, horsepower, weight, acceleration, model, year, origin, all these things in the form of numbers. But the last column you can see car name, it is not a number at all. It is in the form of string. It is a string data type. So this data you won't be able to directly process with your machine learning at all, because there is no option of giving those strings to your machine learning model. I'll tell you a few steps where you will be able to do to convert the string into number and then process with your model. Then some few analyses, say data.d types. D types, it'll just give you what is the data type of individual columns. As you can see, float, int, you know all those data types. Float data type, int data type. The last one alone is an object data type. So that means last one alone is a string. All others are perfect numbers. So you don't want to do anything with those numbers. The next one, see, it is a exploratory data analysis. Exploratory data analysis in the sense, the next constraint with your data, that is, once you take data from some location, the first problem is there can be some cells which are totally blank, in the sense, say for example, Excel sheet. I think you know the structure of Excel sheet. It is cell representation. See, some data, if it is not available, as a data entry, see, I started entering my data. What will happen is I'll just leave that cell blank. That means that data, I don't know the data. So instead of entering some random data, what I'll do is I'll make that cell blank. That means there is no data at that point. So in such cases, what will happen is that also you won't be able to give that data into your machine learning model. So for that, once you get a data, first thing what you have to do is find out whether you have any null values in your data, because there are repositories where you will get data without any null, that is perfect data, but majority of the cases there will be discrepancies with your data, something like this. So I hope this command, I'll just share you this Jupyter notebook with you. So is null.sum, that is, you are checking whether you have null data in your data set. So once you finish this, you can see horsepower is having 6 data which is blank. That means that cell is blank in your Excel sheet. That is, there is no data. So such data, you won't be, that is also a problem with your data. You won't be able to, once you give this data directly into your machine learning model, it will tell you, see, there are null values. I don't know what to do with your data, so I can't process. So machine learning will tell you an error saying that null, I'm not able to accept those null values at all. So that is the next thing. So first step, find out whether you have any null values in your data, and filling your null values. The very basic strategy is you can what we will do is we can delete all those rows which are having null values. That is the very basic things which you are able to do. But maybe, say for example, if you start deleting, there are chances of you are losing your data, because say 100 columns, so many columns, 100 rows of data you have, that is 100 data points you have. There are situations where data is missing at so many, that is, those blank cells are there at so many places. If you start deleting, maybe there is a chance of you will ultimately end up with deleting so much of your data, and you have only a small data available with you. So that is not an advice method at all. So what you will be able to do is, there are techniques where you can assume, say for example, I'll tell you very simple example. Say for example, I have a sensor in my classroom. Continuously, I'm sensing my temperature continuously with, say, 10 minutes, I start sensing my temperature. Say, for example, that is my data. So at 3:30, I got a temperature of, say, 25. Next 3:35, actually, the sensor has to sense the next 5 minutes. But say some hardware error, the sensor stopped. Again, at 3:40, it starts sensing again. It made us, say, 25. So the in between or cell is blank, but you can assume, see, previous temperature is also available, the next temperature is also available. In between, if you don't know also, instead of deleting that entire observation, what you can do is you can try to fill that data with, say, the previous data or the next data, or say I have an age column with me. Some ages are missing, say age of students in my class. So if say in my class, maybe say 12th grade, students will be almost the same age. Say maybe few students will have, say, 17, few students will have, say, 16. Majority of the students say it is 17. So instead of deleting that student with age row missing, what we can do is we can fill that data with, say, majority of the age is 17. So maybe most probably the student which age is missing will be of age 17. So you can fill something like that. Okay. So such a filling is possible. So that is the next step we can do. Just find out whether you have any missing details in your data. And depending upon the detail which you have, say if it is an age case, you can fill the missing age with say majority age. Say if salary is missing, maybe I can say I can fill that with this average salary or something like that. So some strategy you can apply and you can fill those missing data. That is very, very important in your data, because when you collect data from GitHub or UCI, wherever you are collecting your data, there are chances of missing data. So you should have some proper mechanism to fill your missing data. Then I think this already you are familiar with, like visualize and see how your data is behaving. That is, if you this plot is called your pair plot. Say I have an output column. Say I want to predict a value that is called salary. I just want to predict salary of a person with some information I have. But the information which I have is totally irrelevant. Say for example, I have a column which is nowhere related. Say for example, I have number of members in the family. Say the last column which I want to predict is my salary, and my one column I have how many members I have in my family. So there is no relationship between the number of members in my family and my salary at all. So in that case, what you can do is you can just visualize and see how the data is correlated. So this plot is called your pair plot. You can do this plotting with Seaborn. So this pair plot, what this will do is it'll pairwise it will start plotting the correlation between your data points. So as you can see these two pairs, MPG and say this is called my horsepower. So it is this type of relationship you have. See, this also it is somewhat you have related. Say for example, if you start plotting height and weight, you will get a positively correlation. That is, as the height increases, the weight will also increase. It is a common strategy. It is not compulsory. Or whenever you are increasing height, your weight will also increase, but almost. So there is a positive correlation, or it can be a negative correlation. So understand what type of correlation you have between your data and the value which you're going to predict. So all these visualization you will be able to do. So this is what visualization, maybe you can do that in later stages. The next one, the first point I told you, say for example, if your data is in the form of string, as I told you, it is in the form of a string, there is no point in giving this string directly to your machine learning model. So what you have to do is somehow you have to convert the string into a number. So a very popular strategy is available to convert these categorical data into numbers. One is called one hot encoding. Another one is called yes, ma'am.
If I can interrupt you in between, I just wanted to, you have already gone through the logbook of the grade 12 Capstone project, and you have seen the project requirement and all.
Yes,
so
yes.
do the students at the school level also need to do something like this as extensively, or can they scale it down? Because
yes, you can, ma'am, because that is what my worry was, because they should, or you can select your data in such a way that there is no string values in your data set at all, so that you don't want to do all these processing, ma'am, because
right.
it'll be easy. Or else what you can do, you can just drop those columns which are having categorical values, because the converting this, because if you have a string data in your data set, you won't be able to process that with your machine learning algorithm at all. So the easiest strategy you can apply is just drop that. The implication to that is maybe there are chances that your accuracy will reduce, because that category is significant for your prediction, but that is the maybe for a 12th grade student you can stop or restrict something like that. So that is perfectly fine, man. That is perfectly fine. So what you can do is all these steps which I'm going to do is with the conversion of those things, that is the conversion of your string value into numbers. So that maybe totally you can omit, but the null value filling, if you take data from the public repository, there are chances
there will be values which has got null values. Yes,
because the thing is, if you start dropping those null values, there are chances significant amount of your data is lost.
Okay.
Because once you start deleting, wherever you have those empty cells, if you start deleting, you will keep on deleting, and maybe say out of 100 columns, you will delete say 25 or 30 columns. What will happen is, again, you will start reducing your data. It will affect your model. So maybe filling, again, I'll tell you, there are very simple filling techniques that is called forward fill and backward fill. That is, you don't want to do any mean median mode. You don't want to find out anything. If a cell is missing, take data from the previous cell, fill it over there. Just copy. You can have such methods available, ma'am. Perfectly, that is possible. You can have you can just find out. It is called forward filling or back filling. That is, if the cell is missing, you can fill with the next data, fill it over here, or the previous data, fill it over here. Very simple. Very simple. You can finish it off.
Okay, and just one more doubt, like as when you were going through the project details about the Capstone project,
Yes.
I remember reading somewhere they were saying that your project need to be something that you develop. It could also be a research-based project.
You can, ma'am. That is what. Say for example, if you want to collect your data, you can start collecting your data. Say some questionnaire, you start collecting your data instead of taking this data from the Uci Repository or a GitHub. Take those data in the form of, say, numbers. You can start collecting, key in all those data into an Excel sheet. Then you can use that Excel sheet for your analysis. That is perfect. That is perfectly fine, ma'am.
Yeah, because my concern here is that since we are dealing with children of age 17 and 18 and probably 17, 18 who are in grade 12, and we will only get a few months to, take them through this particular whole process of, and there are other topics as well. So how do we go about implementing the whole Capstone project?
Now, first thing what we can do is either collect using a Google form only integer data. Say some 100 people, very simple, very small data set you can start collecting, ma'am. So once you start collecting, there won't be any missing data, because if you make a Google form compulsory, the field compulsory, of course they have to fill something over there, so there won't be any problem with your missing data.
Right.
Then collect data only in the form of numbers, ma'am. Right. That is perfect. That will be very easy.
Yeah.
Or
Thank you.
Collecting from the Uci repository or GitHub, make sure that you are dropping all other columns other than your numbers.
Okay.
That is also fine.
Okay. Thank you so much. Sorry for interrupting your flow.
No problem, no problem. So once you finish all these things, the developing a model is quite easy. That is, you are training your model, testing your model. That is, you with the say, if you have 100 data points with you, with 75 data, you will train your model. With the 25 data points, you will test your model, because training in the sense, say for example, is something very similar to which you are teaching a kid how to identify a car. So normally what you will do is you will show him a 3-year-old boy, you will show him a car saying that this is a car. So in mind what he will do is, yes, you have 4 wheels, you have a shape something small, then color something like this with the 4 doors. He'll identify, yes, this is a car. The next type of car also you will show them and show him and say this is a car. Again he'll understand, okay. So after seeing 10-15 cars, he'll have a generalization in his mind saying that whatever you have four wheels and all these things, it will be a car. Then see all these things you are teaching him or training him. Finally, if you want to test, you trained him by showing, say, 10 different type of cars. Then you are showing him a totally different car which he is not familiar at all, and ask him what is this. So that is exactly same as your training and testing. You have 100 test points with you. With 75% of your data or 80% of your data, you will train your model. You will understand, yes, this is what my data is all about. Then the rest of the 25% or 20% of your data, you will test your model. So your accuracy of your model purely depends upon how your model is performing in your test data. So for training and testing, what you can do is take your data, say for example, house price is what you're going to predict. So for that, what you have to do is house price is your prediction value. The rest of the things, that is number of rooms, number of bedrooms, number of bathrooms, the area, all these things are called your independent variables. And the house price is called your dependent variable. That is the next major thing you have to do. You have to split your data into X and Y. X and Y in the sense, all the value which you are going to use for prediction is called your X. That is number of rooms, number of bathrooms, number of bedrooms, number of square feet. All these things are called your X value or independent variables. The value which you're going to predict is called your Y value or a dependent variable. So you split that into X and Y. Then, as I told you, if you have 100 data points, you have to split your data into training and testing, because you have to train your model. Then you have to test your model with your testing data. That is a general structure which we are going to do. Ma'am, somebody raised the hand. Jyoti,
Yes.
ma'am.
Ma'am, can you hear me?
Yes, ma'am, please.
Yes. Ma'am, actually, you are telling the programming side, ma'am. So now what I am having the doubt is, we are having the project team roles for the students. We are assigning like that. So in that portion, we are having data expert, information researcher, designer, prototype builder, and tester. Like this, these are the different portions. So now you are explaining, so it should be done by whom? It should be done by different students, or how to give divide these portions into different groups like that.
Ma'am, I don't know whether data collection can be done by a single person. Then this data filling, that is, if the missing data filling, all those things maybe can be handled by a different student. Then the splitting, because you know, ma'am, the coding level, the training and test split is only this much. That is, the code is only this much. You will be able to split your data, or say rather than coding, doing this with the coding, maybe is there any possibility of manually, say if you're collecting with a form, say if you have 100 data points with you, maybe you can, I don't know whether I'm telling it correctly, you can ask the student to manually split your data into training and testing. Maybe,
yes, it's difficult.
because the thing is, if you apply this training and testing functionality, you know, ma'am, there are chances of, say for example, a value is there as, say, 0, 1, 2. Two values are there in a column. If you apply this train and test split, there are chances that your training data will contain only 0 and 1, and 3 will totally go into a testing set. There are chances of.
Okay,
so what will happen is, see, you are trained for only 0 and 1. The value for 3, that rows, everything is going to a testing data, so that you won't get that accuracy in your result at all. So in such cases, maybe if you are doing manual training and testing split, maybe I don't know, maybe one student can be allotted like that. Other than that, I don't know, like data collection. Ma'am, will you please tell me those categories once again? Data collection.
It is given like this: project leader, data expert, information researcher, designer, prototype builder, and tester.
Because prototype building is in the sense what prototype you are going to use. That is, prototype building is, you have so many regression techniques are available. Are you using a linear regression or a decision tree regressor? But I don't know whether students will be able to know up to this much. I don't have any idea, because even regression, I don't know whether they are familiar with this regression or not.
Regression and all we are teaching, ma'am, in 11th standard. Regression, correlation, everything is in the portion.
Okay, perfect. Yes. Maybe you can ask them to do one more thing is, ma'am, if it is a only two column data, you know, if it is only one X value, one Y value, if there are data, but that data set is too simple, I don't know whether it will make up to your entire Capstone project. If only one dependent variable and one independent variable is there, instead of calling this function, you can ask them to write functions in Python to do this manually, because if it is one dependent, one independent, that is, say you want to predict the weight if you are given a height, say for example, very simple case. In that case, actually, instead of calling this linear regression, there are methods where you can do Python code to write this linear regression manually rather than calling this function. So maybe you can, but that data set is very simple. I don't know whether that is enough for your Capstone project, because very simple it is.
Okay, ma'am. I was just having a doubt that in this code, how could we divide into these many person?
Because this
I understood now.
you have to actually,
Yes.
if you directly using this, this is the only line, man. Linear regression dot fit. That's it. Then dot
Yes.
predict dot compile. Then again, you can one more thing. Maybe you will be able to decide upon what error metrics you are using, ma'am. RMSE, R square, mean absolute.
Yes. Root mean square.
Those
Yes.
choices maybe you will be able to make it. So only the data analysis part, maybe you can ask them to do some visualization of your data. Say, visualize your data and interpret something out of your data. That maybe you will be able to do with maybe one student.
Okay, thank you, ma'am. Thank you.
Similarly, maybe, but I don't know whether how far the students will be able to use this linear regression, but simple linear regression, there are possibilities. That is one X and one Y. That is one dependent variable, one independent variable. There are chances you will be able to write simple Python codes, and I think it is in the form of a scatter plot and a line fitting. This is what a very simple linear regression talks about. So if only two variables are there, maybe you will be able to do, or you can make the student to do that manually with some arrays list with Python. So if you want, I can share you that code, ma'am. Very simple Python code, but the thing is that is common for all.
Okay, thank you, ma'am. Because for artificial intelligence in CBSE schools, science students with the science students, no, commerce and humanities students are also coming.
Okay.
So we have to think about them also. So there comes the problem.
Okay.
When we are giving the project, we have to give them some data collection like that to those students, and the coding portion to science students we are supposed to give.
Jyoti ma'am, yes, these they have towards the end they have something called a marketing and communication leader, video producer, designer. We have teams like that, right? So those can be given to those children who have a flair in that. And the students who are interested in developing a prototype or into the coding can be assigned as, prototype builder. And there can be children who are very good in coordination, or, they are very good in communicating with different people in the team. So they can keep track of the team's progress, and they can keep track of the timelines and things like that. And maybe once the project is all developed, another set of students can just test it. But I don't, how many children do we have in the class?
So, ma'am, in our school, we are having 22 students, and we are doing 3 projects as now, and we have divided like this. Commerce and humanities students are given like this. But this testing portion and this coding and prototype, these 3 portions I have assigned to the same person, because I feel that it is coming in the same scenario. So that's why I asked Dhnaya ma'am that I have done it right or not. I have to check.
I think it can be done according to a teacher's discretion. They are only asking for the sake of convenience that, okay, if you have such a big team, everybody should be involved in doing this project. So we can, divide them like this. Now, depending on, like, for example, if I go ahead right now for my grade 11, we have only 5 students. So I cannot have 7 or 8 roles, right? Because all I have is 5 students. So for that 5 students, I will have to decide, okay, who will do this and who will do this particular part. So I think, Jyoti ma'am, what you're doing is the way to go about it.
Yes, ma'am. Okay.
Yeah.
But when experienced person like Dhnaya ma'am tells it is right, no?
Yes.
We are getting more confident. We are going on
confidence. Right. Yes, very right.
That's right.
Okay, well, that's what, because normally what we will do is we won't collect the data at all. That is data collection. Normally, very rare cases we will use data collection. So maybe you can ask few people to collect the data, then visualization or interpreting the data can be done by somebody else. And this model training and testing can be done by some other group. Maybe you can divide like that or something like that.
Thank you so much, ma'am.
Okay, ma'am. So these are about actually coding part. It is quite easy. So what we can say, those students who are interested, maybe you can ask them to apply 2-3 models. Those who are interested, I don't know. Again, you have a regression. If it is just a regression problem, you have linear regression. I think I have given here. It is a decision tree regressor. You have random forest regressor. So you have so many prediction mechanisms are available. I'll tell you this package. It is called sklearn. I think you are familiar with this package. This sklearn is having so many regression algorithms are available. So maybe those students, those who are interested, you can take very simple 2-3 regressors and make them compare how the error is. That is, the error is going down, or is it increasing, or is decreasing. All these things you will be able to do. Again, I don't know, ma'am. Frankly speaking, once you do this training and testing split with functions, it is a random split. It is a random split. Again, you have to give some parameters to make it fix. I don't know how far it is required for your students. So that is what I was telling you. If the data set is very small, you can make them split it manually for training and testing rather than using these functions. Because functions, I don't know how far we will be able to teach them also. So these are about general regression techniques. Something similar, you have classification also. Classification in the sense, this is what, say, the data I'm taking from the GitHub page. So classification is whether he'll purchase or not. That is the classification type of problem. See, previously what we were talking about is predict the salary, or say predict the house price or something like that. Now it is either it can be a 2 class, that is whether he'll purchase or not. Is the mail is a spam or not? Whether he is going to get promoted or not. So a 2 class classification problem you can have, or you can have multi-class classification problem. Say for example, the iris data set, you have 3 kind of flowers based upon the sepal length, petal length, sepal width, petal width. You are able to classify this as 3 classes. So these are the second category of very simple problems you will be able to say. You have a user ID, gender, age, estimated salary. Ultimately, I am going to predict whether he will buy a car or not. So something similar strategies you will be able to apply. You have training and testing split, and you have logistic regression. You will be able to apply logistic regression. Again, in a logistic regression, the thing is you will be able to change the metrics. It is not RMSE R square. It is a confusion matrix, F1 score, or accuracy. All those things you will be able to assess your model using these matrices rather than your R square and RMSE matrices. So these two are the very simple problems, that is either predict some values or predict some classes. So rather than logistic regression, again, you have so many other regression techniques. The decision tree classifier is available. All those classifiers are available in the sklearn package itself. Directly you will be able to use. So ultimately you will be able to get a confusion matrix like this. That means in your testing data, in your test data, 66 is of class 0 and predicted as 0. 24 is class 1 predicted as 1. This 2 and 8 is misclassification. One more thing is, it is not possible to exactly predict. That is, even in the regression, you can never predict exactly this is what the salary which you're going to get, or exactly say this is what is the house price is all about. So somewhat similar, you have a classification also. 0 will be predicted as 0, 1 will be predicted as 1. That is a perfect case, but 100% accuracy you will never get in your data. Whatever AI you are applying, even if it is a deep learning or AI, there is no concept of 100% accuracy. You can predict with some accuracy. That is the only thing you will be able to do. So this is the data for some classification data. So maybe these are the very two simple techniques or projects which you will be able to ask the students to do, because NLP, image processing and all, it is actually again going into the deep of image processing, even natural language processing, in the sense the language, that is the sentence learning is tougher than this, because instead of this 1935-26, you have a set of full sentences with you. Again, the problem of sentence you won't be able to do give directly with your machine learning model. You have to convert those sentences into again numbers. So there are technologies, something like bag of words, TF-IDF, so many mechanisms you have to apply for doing sentiment analysis and all. Recommendation, I think you will be able to do. Recommender systems, there are chances you will get numeric data sets available. So this is what I thought I'll be able to explain. Very simple regression and classification, maybe the students will be able to do. But recommendation, NLP, image processing, I don't know. Maybe those who are really interested and the students are really interested to do, maybe they'll be able to.
Okay. So I think you would be sharing your Jupyter notebook also. Yes. So the teachers who are taking those sessions can benefit from that.
Yes, I'll share all these things.
So, yes. So I hope, are there any questions for Dhnaya ma'am? I think we have come to the end of the session. Because all the schools have just started taking AI, there are not many teachers who are already in the grade 12. Many of us have taken it only this year. There are very few who took it last year. So like Jyoti ma'am is one of them, and her students are in grade 12 right now. For many of us, it's a grade 11. For some of us, it's 9 and 10. For some, it is grade 6, 7, 8, because CBSE has started artificial intelligence as a subject from grade 6 onwards for CBSE students. And in 9 and 10, 11 and 12, it's the main subject, like just like your computer science and informatic practices or any other subject for that matter. Artificial intelligence is one of the core subjects. But as Jyoti ma'am mentioned, that there are students from multiple streams who would be coming there. And this forum was basically started because all of us have attended numerous webinars and workshops conducted by different organizations and agencies. But in order to implement it in our classrooms, like we've been taught concepts, we've been said, okay, this is this, but then how to bring it and scale it down for our children was never mentioned. So I think that was the very reason that we have started this forum. And this was the 15th session. I would be very honest, Dhnaya ma'am, that I could only make a little bit sense of what you are saying, because I am not yet in that place where I would be able to follow all that what you said. But I got a fair idea about when my children go to grade 12, how do I guide them in doing a capstone project? And I'm sure that all the other teachers have also got an idea about how to go about it. All of us are in a learning path, and we are extremely grateful to people like you who volunteer to come and take sessions for us. So on behalf of this entire teacher community, my heartfelt gratitude for coming here and sparing that 1 to 1.5 hours of time and helping us, go through this concept. So now I'm sure that later when we will take up these topics, we will go through this again, and at that time it will make a little more sense to us, and we will be able to implement it according to our children. So thank you once again for coming here and taking us through this topic. I understand it's not an easy task to take a very technical, a very dull topic, so it's not very fancy, and you'll not be able to understand. And normally we have a good number of teachers who join in, but today most of them are having meetings, or they are in their classrooms, or they are tied up with something else. But we will surely be sharing the link with our teacher community. And I would also like to thank all those 14 teachers who are right now live in this session. For us, the numbers never matter. 14 teachers means they will go to 14 different organizations, and those children would benefit over there. So thank you all for joining us this Saturday afternoon, which is a very difficult task to do after lunch, to come and sit and you learn something as dry as this. So, but Dhnaya ma'am was very simple. She tried to simplify it for us. And I'm sure that we will keep these learnings in mind. I've just posted a link that Dhnaya ma'am said, which we made, the Scikit-learn and GitHub we already have. And we know how to take the Jupyter notebook also. Then once Dhnaya ma'am shares this Jupyter notebook, I'll be sharing it across in the group. So whoever wants to refer it can refer from that Jupyter notebook. So thank you again. And I think I'll see you all back next Saturday And next Saturday, we have our own very Nilima ma'am who will take us through not something which is related to AI, but all the teachers wanted to learn something about how to make good posters and how to make good this in Canva. And she's one of the expert in Canva. So she will be actually taking us through Canva for next Saturday. So thank you, everyone. And thank you once again, Dhnaya ma'am.
Thank you so much, ma'am, because I was machine learning, AI and all, we are learning this as a subject throughout the semester. So I can really understand your difficulty in implementing this to a school student of grade 11 and 12, because
Right.
grade 11, I don't know how he is going to do if he is having such a project. Maybe
Yes.
I'll be doing because really, if you want any help, ma'am, of course I'll be able to do, because managing school students with this topic, I don't know how it seems to be very difficult.
Actually, Dhnaya ma'am, the thing is, no, as you said, we also thought that teaching Python is very much difficult for the 11th standard student when it is implemented first. But now Python is being taught for class 6 student. They have started from 6th standard. So now when we think of 11th standard, we are thinking, why can't they do this kind of project? So as time passes, no, the technology is improving and our younger children are getting more talented.
Yeah,
so
they're getting
we are
hooked to the concept of technology at much younger age. So very true. So, these projects would not be as difficult as the children would come, because they will be able to make more sense of what we have just seen by just a little guidance. So I think if we guide them, they would be able to do this. So yes,
sure.
Thank you everyone for your participation.
Thank you, ma'am.
And see you all next Saturday. Thank you, Dhnaya ma'am, once again.
Thank you, ma'am. Thank you so much. If you want any help, you can mail me, ma'am.
Sure.
You can share my phone number too.
Yes. There are teachers who are in grade 12, as I mentioned, so they would definitely require a little bit of handholding. So in case if they are stuck somewhere, I would share your number with them and they can get in touch with you.
So happy that at least I'll be able to, if I'm able to, I'm so happy to help you people at all, because really I can understand the difficulty. Thank you so much, ma'am. Thank you so much.
Thank you. Thank you, everyone.
Ma'am.
Yes,
Happy Teachers Day for all.
Thank you so much. Thank you so much, Jyoti ma'am, and thank you everybody. Yes, tomorrow is a Teachers Day. It's very special for all of us. So wishing everybody here a very, very happy Teachers Day. May all of you stay safe and healthy, and may your families be safe. And may God give us this wisdom to guide our children in the right path. And may we always love them and nurture them lovingly. So happy Teachers Day to one and all from me also. Yeah, bye.
Bye, ma'am.